1.4, complex numbers. Be prepared to pause the video a lot to make sure you can get things written down, because I will go faster than what likely you can solve and write down on your own. All right, so a quick reminder. When we're evaluating radicals, take the square root of 16. We know that the answer to that is 4. But what do we do if it's the square root of negative 16? You might remember that a negative comes outside and turns into an I. So we would rewrite this as I radical 16. But we already just said that the square root of 16 is 4. So it would be I times 4, but we always write the number first. So we would say 4I. Let's try it again with a non-perfect square. We have the square root of 8, which we would need to break down, find a perfect square that goes into it, which is 4. 4 goes into it 2 times. So we get 2 radical 2. So when we have the square root of negative 8, same thing. The negative is going to come on the outside and be with the 2 that was already on the outside as an I. So 2I radical 2. When you have a fraction under a radical, you can do each part individually. So you can take the square root of the top separate from the square root of the bottom. So let's do our numerator first. Square root of negative 49. We know the square root of 49 is 7. Since it has a negative, it would be 7I. And then the square root of 16 is 4. So we end up with 7I divided by 4. Let's try that again with some non-perfect squares. We have the square root of negative 27 divided by 25. So we would first want to find a perfect square that goes into negative 27. So again, we're going to separate that numerator and denominator. Break down the numerator. 9 goes into 27 3 times. So we pull that I on the outside to get rid of the negative, and then we have square root of 9 times the square root of 3 all over. Square root of 25 is 5. And then in our numerator, square root of 9 is 3, so we can write it as 3I radical 3 over 5. We would want to check these coefficients out in front, the 3 and the 5. If they had any common factors, we would want to divide those out. But you can't touch the stuff that's underneath the radical, so that would need to stay the same. All right, let's talk about adding and subtracting complex numbers. When you add and subtract, you just combine like terms. So here we're going to combine the numbers that don't have the I, 4 and 6, which is of course 10. And then we're going to combine the numbers that do have the I. So 6I plus negative 5I is just 1I, or I by itself. You don't need the 1 there. Likewise for subtraction. We want to combine the numbers that are like terms. So we'd say 4 minus 6. 4 minus 6 is negative 2. And then here we have to be careful. Negative 6I minus a negative 2I. So we're distributing that negative all the way through. So minus a negative 2 is really adding 2. So negative 6 plus 2 is negative 4I. So when you add and subtract, just combine the regular numbers together and then the numbers that have the imaginary together. And that's it.